Hello everyone, Happy New Year. Hope all of you are doing great. Welcome back to my channel. For those of you new to the channel, I'm a digital analytics consultant and I'm very enthusiastic about new technologies in the data world like customer data platform. So if you're working on any of the Adobe tools or Google Analytics, Adobe Target, Adobe Audience Manager, tag managers like Telium, Launch, DTM, or any CDP related technology, this is the channel for you. So today we are going to discuss Adobe Target Sample Size Calculator. We'll discuss what are the key jargons like confidence level, statistical power, lift, how to interpret what the calculator tells us. We'll do some use cases to understand them better and also discuss some common questions that we get from the clients. So let's get started. So the first term that we are going to discuss is statistical significance. Now statistical significance is basically your false positive error, right? And confidence level is defined as 100% minus the significance level, right? So when we talk of confidence level, if we say confidence level is 95%, it means that every time you do this test, there is a 5% chance of detecting a statistically significant lift even if there is no difference between the offers. So basically, if I have to get it, confidence level less than 90% means there is no evidence that there is a difference between the conversion rates, right? If it is 90 to 95%, it means that there is weak evidence. If it is more than 95%, there is moderate evidence, right? If it is more than 99%, there is strong evidence, and if it is more than 99.9%, there is very strong evidence that there is a difference between the conversion rates. So this is how you understand statistical significance. The most important way to understand is that every time you do a test, right, the confidence level is the key metric that will indicate how much chance is there to detect a statistically significant lift even if there is no difference between the offers, right? Moving on to the second one, statistical power. Now statistical power is basically your probability of detecting a real difference in the conversion rate of a certain magnitude. It's your false negative, right? Statistical significance was false positive. This is false negative error, right? A recommended number for statistical power is 80%, right? So when we say that the statistical power is 80%, it means that the test has an 80% chance of detecting a difference equal to the minimum reliably detectable lift, right? The test always has a lower probability of detecting smaller lifts and a higher probability of detecting larger lifts. The key point, if you have to remember, is that statistical significance recommended number is 95%, statistical power recommended number is 80%, and statistical significance is your false positive error, statistical power is your false negative error. If you remember this, that is enough. Okay. Moving on to lift. Now lift is basically the percent difference between your control KPI and the variation KPI. So if my KPI is sign up rate, the percent difference between the control sign up rate and variation sign up rate will be my lift. We will understand these metrics better when we will do the demo, right? So don't worry, we'll talk about these metrics more. Okay. Now we have discussed these three key metrics. Now we will look at the calculator itself. Okay. So if you look at this calculator, you can see these metrics, right? The recommended numbers are here, right? You can see confidence level, it's 95%, statistical power 80%, the recommended numbers, right? Then the baseline conversion rate is given. Now baseline conversion rate is nothing but the conversion rate of the control offer, right? Then next is your daily sample size. So this can be your visitors, this can also be visits, right? It can also differ in some specific scenario where you have a different KPI, right? Where your primary KPI is not based on visits or visitors. So not necessary it has to be visitors as it's mentioned here, okay? Then there is number of offers or variations, including control that you have in experiment. Then as you can see, the calculator is predicting the results based on these numbers, right? All these metrics are there, right? Now it's very important to understand that there are opportunity cost of running a test for a long time with the risk of false positives and false negatives, right? This is very important. That is why you have all this calculation being done here. Now let's look at the relationship between these variables. For this, we'll go to the live calculator itself and play around with it to get a better understanding. So this is the sample size calculator that we have, right? And we have the recommended numbers for confidence level and statistical power that we talked about, right? 95% and 80%. Then there is the baseline conversion rate that we discussed. It's the conversion rate for your control offer. You have the daily sample size, right? And then there is the number of offers including control. So whatever number of variations you have plus the control. Then you have the results that the sample size calculator predicts based on these numbers. So you have the daily number of visitors per offer, right? And then there is for each lift how much time you will take to complete the test, right? There is these different things like sample size per offer in terms of visitors and in terms of conversions for these different lifts, right? Then there is conversion rate of the alternative, right? How much difference in the conversion rate is there? All these metrics are here, right? And they have also given the days and weeks to complete the test. Now it's very important for us to understand the relationship between these different variables. So for a 10% lift, it will require 7 days to complete the test. And this is one of the most important questions asked in the certification exam as well, right? The relationship between these different variables. Like for example, if you change the confidence level, how will the time taken to complete the test be impacted? And so on and forth, right? And for that, you need to play around with this calculator to get a better understanding. There are a lot of client questions as well that are asked, right? For a consulting perspective also, you need to understand the relationship between these different variables, right? So if you look at it, if you increase this, right, if you decrease the sample size, right, now the time taken to complete the test has increased. That is why we say that we need high traffic pages for an A by B test, right? Again, if you reduce this, right, you will often be asked that, can we include more variations? Will it take more time if we include more variations? So that is a question that you need to answer based on what the calculator is telling you, right? So if we reduce the variations, it's taking less time, right? It was 5, so it's 7 days, and if it's 3, then it is 4 days for a 10% lift. So this is how these metrics, these variables interplay, and we have to understand that relationship, right? And that is why we say that there is this opportunity cost of running the test for a long time with the risk of false positive and false negative. And there is a trade-off between the minimum lift that can be reliably identified by the test and the number of visitors, right? So you have seen that the statistical power is 80%, right? And if we increase this, right, now the number of days to complete the test has increased for a 10% lift, right? So that is how these variables are interplaying, and you need to understand that. You need to understand the impact on the lift, on the time, and so on and forth, right? So I would recommend you to go through these two Adobe articles. How long should you run an A by B test, right? And then there is another one where you talk about how do I avoid the A by B testing pitfalls, right? So these two are very important articles, right? You have the link for this one here, 10 common A by B testing pitfalls and how to avoid them, right? So this is the first use case where we are going to discuss how to interpret the results, right? So the use case is basically where we have a daily sample size of 5,000, right? The baseline conversion rate is basically the conversion rate of your control, or you can take the 90 days average, right? It's 8% here. Then the number of variations that we have is 2. So including control it becomes 3. And then we have the KPI as the enrollment rate, right? The sample size calculator, if you put in these numbers, it will predict that it requires 2 weeks to complete the test for a 10% lift, right? Now the idea here is to understand the concept more rather than the calculations, right? We'll look at the data that is collected after 2 weeks of running the A by B test, right? We have a page wherein we have a CTA. People click on the CTA and move on to the form. We are running the experiment on this page wherein we have the CTA, right? So as you can see that we have built this journey in the table when we are analyzing the results, right? You have the experiment, control, variation 1, variation 2, then we have the sample size, right? So 25,000 people are coming to the page which has the CTA, right? Then there is CTA click rate, which is 20% for control, 24 and 22 for the variations. Then there is enrollment rate, which is basically your form completion rate, that is 8% for control, and similarly you can interpret the numbers for the variations. So as you can see here that the variations are performing better than the control based on both the primary KPI, which is enrollment rate, and the secondary KPI, which is CTA click rate. So what you will analyze, what you will interpret is that V1, variation 1, has a lift of 10% over the control, right? And variation 2 has a lift of 5% over the control based on the primary KPI, that is enrollment rate. If you plug in these numbers in the sample size calculator, you will also get the same, numbers. This enrollment rate 8.8 and 8.4 for 5% lift and 10% lift is also visible in the sample size calculator. So this is a very simple case. We were just talking about how do we go about analyzing the results. So let's look at how the numbers look like in the sample size calculator for the given use case, right? So we had the sample size of 5,000. So I've plugged in that, and the number of offers, as you can see, it's 3 here. The baseline conversion rate is 8%. So as you can see, for a 10% lift, it's showing that it will require 2 weeks to complete the test. And then for the conversion rate that it is showing for that alternative that can be detected with 80% probability is 8.8%. And again, for a 5% lift, you can see it's 8.4%, right? And then you also have the sample size per offer that you need to have, right? So this is how the numbers look like. It's very important to see these numbers in the sample size calculator before we discuss the next use case. Again, we have the same use case, right? The sample size is 5,000, conversion rate is 8%, right? KPI is also the same, enrollment rate. Now what we'll do is we will look at the data that is collected after 1 week of running this test, right? So as you can see that now the sample size is 12,000, right? And then CTA click rate and enrollment rate are the same, right? But in variation 1, both these KPIs are not performing well when compared to the control, right? Both are showing a negative lift when compared to the control. Variation 2, enrollment rate is showing a positive lift. CTA click rate is same as the control, right? So what will the clients tell you? They will tell you that you remove this not performing variation from this test, or you stop the test, right? What your recommendation should be to continue the test until the estimated sample size is reached for each experience, despite the variation giving negative lift. Now it's very important to note down that you also have to look at the confidence for these numbers, right? So This is how we go about a common question when the client say that you stop the test or remove these variations that are not performing, right? Then what you need to go about, what you need to tell the client, what your recommendation should be. That is what we discussed in this use case. Let's move on to the next use case. Now again we'll have the same details, right? Everything is same. Again we'll also look at after 2 weeks of running the test, right? We'll look at that data. Here what is the difference is, as you can see in this table, right, the sample size is same, right, because it's after 2 weeks of running that test. Now in variation 1, the CTA click rate is not performing well when compared to the control, right? It's showing a negative lift, right? Whereas in enrollment rate, it is showing a positive lift. In fact, when you look at the enrollment rate, variation 1 is also performing better than variation 2, right? So this is where the difference is. You have two KPIs. One is your primary KPI, one is your secondary KPI. Both are telling a different story. Here when we take CTA click rate, variation 1 has a negative 10% lift in regards to control. When we take KPI as the enrollment rate, variation 1 is performing better than control with a 7.5% lift. So now what you need to do, what should be your recommendation, what should be your decision? The results become inconclusive in this case. It's difficult to make a decision. So what we do is we do further analysis or we recommend to do a further iteration of the test. And as I noted down previously also, that you have to look at the confidence for the numbers, right? It has to be a 95% plus confidence before you take a decision, right? So this is all about what we wanted to discuss. So that's all for today. Hope you are able to understand the sample size calculator better now with these examples. Do like and share the video. Subscribe so that you don't miss out on any helpful videos. Let me know in the comments on any useful topics that you need help on, and I'll be glad to share guidance on the same.